Thanks a lot for being here so late. I imagine most of your brains are kind of mush at this point after so many pretty crazy talks. So thanks for having the patience to deal with this. So I'm going to talk about Dato, which is a framework I've been working on with a few people. I'm going to talk a little bit about the ideas and the motivation behind it. We'll take a quick look at kind of how it's built and what it looks like to use it. And then I really kind of want to focus on the ideas that fall out from the design. So first of all, I'm Sean. I think my official title is some guy, often known as Hey You. So if you see me in the hallway, just feel free to scream out Hey You. I work for a company called PayGarden. We are in the alternative payment space. We allow any US vendor to essentially accept a gift card as a form of payment for digital goods. The reason I mention them is they've been super supportive for me kind of working on this and preparing this talk, so I wanted to give a shout out to them. So I want to start this talk off with kind of a quick hypothesis that I think probably will resonate with everybody. Whenever we talk about front-end and back-end, there's kind of an implicit middle end to some degree, which kind of generally speaking is not a very valuable area, kind of how we tie our front-end in with the back-end. It's also not very fun to work with, and ideally we can kind of enable it to go away. And we've seen this trend kind of happening more and more over the past several years. So, several years ago we had kind of Meteor and Parse and Firebase. And more recently things like Falcor, Relay, GraphQL, that kind of thing. And what happens is we push the backend developers further and further back where they can focus kind of on the business logic that's specific to their company. Right? That's where they actually provide the value, not in the plumbing in the middle. And the front-end developers get pushed further and further towards the front end, where they focus on the differentiating apps, points of their apps. So kind of the user experience and the design and the performance and that kind of thing. And so Dato is kind of really motivated by this same set of ideals, where ideally we want to kind of remove that middle layer as much as possible for kind of modern apps. So with that in mind, kind of one of the high-level goals, or probably the highest level goal of Dato, is to make building modern apps incredibly easy, and that the apps that we build with it should be incredibly easy to refactor. So I know it sounds kind of vacuous, but it's actually worthwhile to step back and think about what is the high-level goal that we're actually going for. In particular, whenever you're thinking about introducing a new technology or a new technique, whenever you're considering the trade-offs, it's often important to kind of consider, are we doing this for technology's sake, or are we actually furthering the goal of making modern apps very easy to build or easy to reason about? To that end, Dato really emphasizes kind of computer-assisted reasoning. And we do this kind of with a very, very strong emphasis on tooling, not only kind of built-in tooling, but also on making it incredibly easy to build custom tooling. Oftentimes we underestimate as developers the value of the computer's ability to express to us data and for our ability to reason about it. So oftentimes it actually would be faster to build a one-off tool to solve a problem rather than kind of trying to build all of the state in your head. And oftentimes this ends up, for developers, this might take the form of maybe time-traveling debuggers, or being able to instantly save and restore states, or look at a replay of a user session, or predictive testing, which I'll talk about a bit later. But also for designers, which are kind of more and more crucial for the differentiating features of our apps. The more independent we can make them, the faster we can allow them to iterate, the more competitive we actually become. So building tools for our designers, even if it's custom tooling in-house, is incredibly important. Whether it's allowing them to kind of query and change the state inside of the app itself, or to quickly refactor and change things with the layout, whatever we can do to make them more independent and to ensure that their output is of high quality and is maintainable over the long term is a huge advantage. So with all of that in mind, kind of what is Dato? So it's essentially just an alternative approach to building apps. It's heavily, heavily inspired by the Meteors and the Firebase and the Parses of the world. But it has a very, very strong bent towards this idea of observability. Kind of at every facet of the framework, from the data storage to the state transitions to the tooling, we really try to emphasize being able to programmatically observe what's happening in your app. So I'll kind of talk about how we do that. So on the back end, we use Clojure. We We also use an immutable database called Datomic, which has some very, very interesting properties. We also then, the backend actually exposes the entire database conceptually to a client. So the client is free to just kind of query whatever it would like. And the server is responsible for applying some security rules and kind of filtering out what the client shouldn't see. But we really want to push security down the stack. It's too hard to kind of keep this as a concern inside of the client side of things. So we want to remove that burden whenever you're trying to iterate from the front-end developer's mind. Another kind of cool feature of Datomic is that it actually has a built-in transaction listener. So regardless of where a transaction happens or originates from, we can actually have a server set up which gets a list. After every transaction is committed to the database, it gets notified and says, hey, an update has happened, here's the time, and here's what changed in it. So we can use that to kind of dispatch on different actions. So you can kind of think of it as like Rethink DB's live queries or Firebase's live updates, but at slightly lower level. And then finally, Dato actually allows you to define server-side methods, which are then transparently propagated to the client as a form of RPC. And so you can kind of use this as a way of saying, in the client very transparently and very easily calling out to the server and say, hey, do some computation for me, or reach out to a third-party API, whatever it might be. On the front end, I don't know what this logo is. We'll have to ask Nikita, but this is the DataScript logo. But we use ClojureScript on the front end, so we get a lot of the kind of universal code sharing benefits that you guys have come to expect. And we also use an immutable database on the front end as well. So we use DataScript. Nikita gave a great talk about that yesterday. And the UI in Dato apps are actually modeled as queries into this database. So components actually declare their queries in the same kind of area as the render function. So you can kind of imagine this is a bit like GraphQL, where the query is co-located with the rendering body. And what this ends up happening, the kind of shift that this induces is that rather than parents passing a huge amount of data to their children and kind of filtering it through as we go down, there's actually a thin amount of data which is threaded through. And this is actually used to parameterize the queries for the children. And so pretty much all of these states at any given time is stored inside of this database. So those of you who are used to kind of Flux's multiple store idea, we kind of go the opposite way. We put everything in a single store. And there are lots of benefits to this, but there are also challenges as well. In particular, if you have, every data structure that you have is kind of a snowflake. You know, it's unique and beautiful in its own way. It's really hard to slice the data up, where now every bit of tooling has to understand how you've structured your user list, or has to understand how your friends are linked together. What we really want is a way of homogeneously representing our data and of querying into it. And what we really want is kind of like a full database, which is what we actually model our entire UI off of. So usually around this time, we get questions kind of saying, if you have an immutable database on the back end, and you have an immutable database on the front end, like how exactly do you change anything? So Dato actually has this very explicit idea of a state transition. So it's going to be very similar to, for example, Elm's architecture, or to Redux's action, where we have a named transition event and a pure function which handles taking the old world and some data and producing the new world. So to give an example of what that might look like, let's say that we're building a button which is just going to be incrementing a counter. This component would probably raise some event, so a counter incremented event. That event will go up to the Dato responder chain, and Dato will take the most recent or the most optimistic database and that event, and will hand it to the first state transition that it finds that can handle this event. So this state transition is trying to increment the counter, and it's actually given the entire database for the entire app. So this includes even the local state for individual components. So what we would do is query into that database and say, what's the current value of the counter? And then the state transition is actually responsible for now giving us the transaction data that we want to use to produce the new database. So for example, we would have said, we query into the database and say the value of the counter was 1, and I want to increment that, so now it should be 2. So the state transition actually doesn't transact itself. It actually takes that data and hands it off to Dato. It's a very, very polite framework. Nobody steps on anybody's toes. So Dato now takes this transaction data, and it takes the old database, applies this transaction, and produces a new database. So now we have three pieces of data: the old world, the new world, and the event data. So this new world is what we're going to render the future UI from. But before we do the rendering, we actually give a chance to achieve some effect. So this is very similar, again, to Elm's way of separating state transitions from effects, which are incredibly important for being able to reason about your tools in an automated way. So in this case, maybe we want to initiate some network traffic after the counter reaches 10 or whatever it might be. So that can go ahead and happen, but this effect handler is never allowed to change the state. Its return value is totally discarded. So finally, we go ahead and re-render, and this loop starts over. So we'll take a quick look at what a component actually looks like. So we're just kind of defining this is ClojureScript. Don't fight it too much. But we're just defining a quick button, which is going to increment some counter. The first thing we do is pull out Dato, the Dato instance from the data that's passed in. We ask Dato, please give us the most recent or the most optimistic database. We query for the row that has a counter in it. We get the counter value out of it, and we simply render at the bottom a string which says current count and the value. So in the middle there, for the onClick handler, you can actually see we have our state transition function co-located inside of our component. So what we're saying is we want to transact into the database, given this kind of Dato instance and a counter incremented function. And we're saying that the row or the entity with this ID, with the counter value, we want to now set a new value to it. And this kind of JSON object-looking thing is actually a bit of sugar on top of what actually happens inside of the transaction for DataScript or Datomic. Actually, what happens is we have to apply two things. First, we have to say the old value was 1, and that's no longer true. So we are retracting that fact. And now we're adding a new fact which says the current value is 2. And so the result of that is then put into the database. The UI is re-rendered, and we have our nice button which says 2. But you'll notice that if we were sitting side by side, your client would still say 1, because all I've done is kind of transacted into my local database. I've produced a new UI, but I've just kind of been playing in my sandbox. So this is the same function, and let's see what does it take to actually turn this into something that is collaborative and is persistent to the server. We simply take this transaction, and we mark it with a txpersist, and we take care of actually shuffling those datums between the server. We apply some security filters, apply it into the server-side database, and notify all the other clients. So this is essentially all it takes to have a collaborative incrementer button. OK, so I kind of sped through that, and the goal was to give just a high-level view of that. So actually, let's take a look at what we can do now. If we have this kind of underlying separation of state transition and effects and observability at each of the levels, see what we can do. So this one is an oldie, but a goodie. Everyone can do this now. I think Elm actually was the first one in many ways. But we can do time travel, right? So we can actually record the state in memory, and we can replay it. So every app that is built with Dato naturally is compatible with these set of tools. So in this case, I'm going to go ahead and run through my chat application. And I'm just kind of changing things. I'm also updating local state there, so whether the menu is toggled and whatnot. And because all of that is stored in a single location, I can very, very easily kind of scrub through and capture all of that. Yeah. So with no additional effort, we can capture everything about this. But to be honest, this is a bit of old hat now. Everyone can do this. So let's kind of up the ante just a bit. So actually, what we do, or what we find very useful, is actually rehydrating sessions from storage. So rather than just something that is in memory, it's very useful to say, what about that thing that happened last week, right? And unless you haven't refreshed your browser for a week, that's oftentimes not retrievable. So in this case, I'm actually logged in as a different user. I'm going to go ahead and create a couple of channels and create a couple of messages. And what I'm going to do then is refresh. And whenever I refresh, the replay is actually destroyed. But what we do is we take each of those transactions and we store them in the server. And so we can just ask the server and say, hey, give us that session back. And we rehydrate it locally in the client, and we can actually scrub through it. So it doesn't matter if it was just something we did right now, a week ago, or a year ago. And not only that, but we can actually go in and change the code for that session. And we can say, in this case, I'm actually reversing the string of the way that the usernames are displayed. And we can say, what would that session have looked like with this fixed code? So we can actually retroactively go back and kind of experiment with old sessions and see if we can fix bugs. So for the next thought experiment, I need to kind of step back for a moment and explain kind of how datomic transactions work. So usually a transaction is like with a typical Mongo, MySQL, Postgres. You insert your data or you update your data in like a function call, right? You say, write this data. The old data is gone. The new data is there. And they're like, there was a transaction that happened, but like it was kind of ephemeral. There was no point, like there's nothing you can point to and say like, that's the transaction. Datomic actually has, you can think of like a whole table dedicated to every transaction that has ever happened. So every transaction gets its own row. So it has an ID, the time that it happened, and all of the transaction data that we saw previously. So everything that was added and everything that was removed in that transaction. But this table is actually something that we can add our own data to as well. So in this case, let's say that we actually wanted to track the session, like which session originated this transaction. So not only can we kind of travel through time and see the database at every single version through history, we can also know like which session was responsible for that particular change. So this is actually a real case that I came across. And there may be better ways of handling this, but this is actually an issue that you may find yourself in an imperfect world. Where let's say that we're trying to enforce some invariant, right? We're not doing a very good job of it, but we say every account field should have a number. It can never be blank. And we think we're doing a pretty good job, but then like we're scrolling through our database one day and we notice a blank field. And at this point, you get to play computer, right? Suddenly your brain is searching through all of the possibility space. Where like, where did this happen? Maybe this happened in like a client-side browser. Maybe it was like a bug in Internet Explorer 8. Maybe this happened in our admin panel. Like who knows like where this originating transaction came from? And who even knows when, right? There's a good chance like I didn't actually store when it happened. Maybe it was from like last year and the bug has been fixed. So you're really kind of stuck to do the computer's job for you in many ways, where you are now struggling to come up with a state and understand like the origin of this bit of data. However, if we are actually able to track the session and the transactions, what I can say is, hey, give me the last transaction that affected this field and this row, and give me the ID of that. So in this case, we find the ID that was responsible for writing that. And then we say, I want to look at the metadata that's responsible for that session. And by default, whenever a Dato client boots up, it tracks a bunch of stuff from the navigator in the browser. So we know exactly the operating system. We know the browser type. We even know the git SHA of the client that's being used right now. So we know the exact circumstances under which this, this transaction was actually inserted into the database. So what we can do is we can actually time travel in our database, go back to the exact time when the database was in a good state. We can extract that exact session. We can use the exact code as used in the client. We can use something like Sauce Labs, where we can actually boot up the same browser and the same operating system. And so we can actually experience exactly where that session came from. And we can scrub through it. We can verify that there was a bug. We can actually write our code and fix it and create a test from that automatically. So with there's no effort on my part now to have an epiphany to try to figure out where did this come from. So then the computer's telling me, like, here's all the data you need to figure this out, and not only to figure it out, but to fix it and to make sure that it doesn't happen again. So some of the caveats that go with this. There are like way too many to list, so I won't even bother. Nobody cares about caveats, right? No, they're important. So you know, kind of scale. It's an immutable database. There are implications to that. It's write limited. We kind of aim for like a Meteor-ish scale. You know, like Facebook or Google scale is simply not a goal at all. In my opinion, nothing scales to Facebook or Google. Like everything is custom at that point, so good luck. But you know, for most of the time, like the apps that we're working on, we benefit from being able to iterate much more quickly rather than like some perceived need to scale very rapidly in the future. So another thing is that data sync is really, really hard. I think we've seen that in a lot of talks today. And it still requires a lot of thought on the strategies that you use. So Dato can kind of hand these strategies to you, like maybe use last write when, maybe you're happy with that. Maybe you have some kind of more domain-specific model that you can apply, so whenever there's a conflict, you can kind of apply some automated merge technique. Or maybe you push that off to the user and you say, we tried to write this to the database, but someone else wrote this first. Like, which one do you want to keep? But it still requires thought on your part. It's not magic. Another thing is that Datomic is a fantastically cool database, but it is a closed source database. And there's a lot of worries that kind of come along with that. Licensing, the convenience, stability, support, they're all concerns that you kind of have whenever you deploy this thing to production and you're running your company on it. And a lot of the ideas that are in Dato are fairly experimental, where they work for us and they work in production, but they may need to be rethought to accommodate the specific needs that you have. And there are actually a lot of other caveats and limitations with the current implementation or ideas that I haven't mentioned so far, just for a lack of time. But I'm happy to talk afterward or find online or talk online. Just hit me up. So kind of talking about future ideas. So one of these ideas that I have is predictive testing. And we were actually able to do this at a previous company, where we store those sessions. And what we would do is actually store a rolling window of the previous n,000 sessions. And so whenever we would actually write some code, before we pushed it, we would take those sessions and replay them against this new code. And then we would say, is anything that we're about to push going to break what people normally do on our site? So it's this idea of rather than taking all of this data that we have that's just kind of floating out there and throwing it on the floor, maybe we can use it to kind of guide our development efforts in many ways. It's this lovely, warm security blanket. You feel very happy whenever you have it. Another one, I'm a huge proponent of generative testing and property-based testing. We saw James give a kind of interesting example of that. But there are cases where a session replay actually has kind of privacy issues, where Facebook can't necessarily be like, all right, here's a stack trace and here's everything that this user typed exactly. But if what we can do is actually take the failing case, that exact replay, as a starting point, as a seed for the generative testing, and then use that to actually eliminate or to narrow down the search space so that we can try to find a randomized and minimized reproduction case of this. Then what happens is you go from having an email which says, here's the stack trace, line 0, undefined is not a function, to here's an email, or so, undefined is not a function, and here's everything that led up to that, and you can just kind of scrub through that, and you don't have to spend any time trying to reproduce the state anymore. So, kind of leave you with an open question I have on my mind recently. So, Dato is able to do this, and kind of like this crazy replay, and all the tools that we build for it, primarily because we work so hard to enable observability at lots of different layers. So whether it's at the data storage layer or at the state transition or the data synchronization, tools are very easily able to kind of pop in and apply automated reasoning and introspection to them. But because it's a framework, it requires a lot of discipline on the part of the developer, and it requires, you have to give up a lot of options as well. So I'm very curious, if you look at what Elm has done with the set of restrictions that it chose, this kind of leads to a different solution space. So I'm very curious, if there was a language which wasn't primarily focused maybe on concurrency or on performance, but rather on observability from the ground up, what kind of tooling might fall out of that? If it was super easy to build tooling on top of this at every level of the stack, what kind of introspection would you think about building? So that's about it. I want to thank Daniel Wolfel. He actually is responsible for building the vast majority of this, and I just kind of talk a lot. And thank you to everyone for kind of sitting through this and being so patient.
We have still some couple of minutes, so okay. You can dive into the questions.
Sure. So do we do time travel on production data? That's the best data to do time travel on, of course. Yeah, it's this kind of thing where, according to your domain, if you have very sensitive data, it may not be something that's available to you, but there are lots of cases where it is fantastically useful to have the computer say, here's all the data you need. And humans are very good at kind of reasoning and having epiphanies. So as much as the tooling can kind of push us up to do that, it's fantastic. So whenever we have a bug in production, we need to do the time travel on that. And we also use the production data for, obviously, the session replay. UI components declare DB queries. Perhaps to some degree. Like, oh, I'm sorry. Yeah, is it bad practice? In my opinion, it hasn't been. So this is actually one of several dozen experiments that has led up to this. So we've done a number of different implementations of different ideas around this. And this is kind of like a happy medium where you're co-locating all of the concerns of your components together. And you simply basically expose this API, which allows the outside world to parameterize it. But otherwise, like, everything that is concerned in that component is self-contained. Storing transactions equivalent to storing actions. So this one is actually quite difficult. So there's a difference between storing, for example, the resulting transaction data, right, or the new database, and storing the parameters which actually produced that transaction. So storing the parameters actually requires a significantly higher degree of discipline on the use of the developer, because now everything that passes becomes a parameter for the state transition has to be serializable. You cannot pass anything which cannot be serialized, or else you can't replay. So we kind of work at a level where you can opt into this, and you can say, like, if it's worth the effort on our part and we're willing to enforce this, then we'll go ahead and get these benefits. Otherwise, like, we don't care. Good resources, I would say, let's talk. Yeah, so there's a bunch of documentation kind of going over the rationale and whatnot, but because of the kind of dependency nature of this, it's still quite difficult to set up. But it'll probably be better within the next couple of weeks, I would imagine. Permission management it's very similar to something like Firebase or Meteor, where it's kind of defined server-side and it's enforced there. The client can get a copy of, like, the permissions as they need, just to maybe do a faster rejection of insertion of data. But everything is ultimately verified by the server. And there are actually quite fine-grained details of this, where you write in a full language. Yeah, so limited data retention policies. So this is why we had, like, the previous N1000, right? So it's kind of like a rolling window of whatever sessions were in this time frame that we were comfortable storing before we had to kind of evict the data, basically. Are we pretending the last 10 years of CS didn't happen and revert to techniques we already know won't work, clients interacting with the DB? So actually, yeah, this is actually one of the caveats I forgot to mention, which is one of the biggest challenges or biggest kind of unknowns right now is that the components kind of see into the structure of the database, and it kind of tightly couples them together. So a migration on the backend can actually affect your components. And so this is why GraphQL actually still strongly recommends a kind of intermediary layer. And so we're kind of looking at exactly how do we build that in without adding a ton of burden up front.
Great. Thank you so much.